Hi, so today in this video we're going to be covering chapter 3.2.1, which is an algebraic analysis of polynomial functions. Now, hopping into it, there are a few things to know when we are talking about this. And number one is we've covered this type of thing before. I don't remember the exact chapter, but a lot of this we're going to be talking about inverses. And basically an inverse is when you swap the x's and the y's. So if this was f of x, then f of negative 1x, which is the inverse, would look like this, y comma x, from our original function. So that's one thing to keep in mind. Another thing is that we've already done before is when we're thinking about finding, like when something equals x or when something equals y, we're looking, number one, we're saying, okay, when f of 3, so that's when x equals 3, so what is y? So that in that case, it would be 1. And I guess I just covered that. So yeah, in that case, this would be 1. Because we want to know what happens, what is the y value when x equals 3? And that's because you usually see an x in there. If you see something replaced, that's still the x value. They just put in a real number for it. Next would be function composition. And we'll talk a little bit more in depth about it in the next video. But basically, we're going to be covering a function added to another function or a function subtracted by another function. And we'll talk about distribution for that. And then we'll talk about exponent rules and how to multiply terms together. So one thing to note for exponent rules, hold on. So exponent rules, when you have two exponents that are the same, when you have two terms that are multiplied by each other, that have the same base, and the base is the term that is not the exponent, so it's just like this x in this case, your exponent is going to be your two exponents added together. So for instance, if we had x to the third times x squared, that will equal x to the fifth. And the reason why we're allowed to do that is because this expanded will be x times x times x times x times x equals, and then that's 5 x's, because this is a 2, this is x squared, and this is a 3, this is x cubed. And then conversely, when you have something like x to the m divided by x to the n, that's going to be x to the m minus n. And for instance, you could have something like x to the fourth divided by x to the third, and that would give you x to the 1. And that's because that can be expanded to be, x times x times x times x over x times x times x, and you can cross those out, and that leaves you with just positive x. When you have any base with the exponent of 0, that will turn it into 1. And that sort of comes back to this rule, where if you had something like x to the 1 over x to the 1, that would be x to the 1 minus 1, right? Which is x to the 0. But this, whenever you have anything divided by itself, it will be 1. Your answer will be 1. And then if you have x to the negative m, that's exactly the same as saying 1 over x to the positive m. And you can sort of reason your way back from this exponent rule with the fractions, because if you had something like x to the 2 divided by x to the fourth, that's exactly the same as x over x, boom, boom. And that leaves you with 1 over x squared. But that's also the same as saying x 2 minus 4, which is x to the negative 2. And so this equals this, basically. And And then the final exponent rule that's going to matter for this class, I don't know if it will matter for this unit, but if you have something like 3x squared, and then you have that to an exponent, like 3, the exponent is going to come down and distribute to both of your terms. So this would turn into 3 cubed times x to the 3 times 2. So that would give us 27 times x to the 6th. Now, with that in mind, let's begin. Our first ones don't start with any exponents. Well, exponent rules. This one is just saying, what is the function value when x equals -2? So we'll do 6 times -2 squared minus 6 times -2 plus 6. And that will give you 6 times +4 minus plus 12, because that's going to be a negative times a negative. And then plus 6. 6 times 4 is 24. Plus 12 plus 6. This is going to give you 36, 42. Yeah, so 42 for that answer. Then when x equals -1, so we'll do 6 times -1 squared minus 6 times -1 plus 6. And that is going to give you +6 plus 6 plus 6, which is going to give you +18. Now, it's asking us the exact same thing when x equals 0, because we have an x in this spot. They're just trying to trick you. So we have 6 times 0 squared minus 6 times 0 plus 6. These turn to 0, and so we have +6. Now 1, we have 6 times 1 squared minus 6 times 1 plus 6. This gets us 6 minus 6 plus 6. So you're going to also get +6 for this. Now for 2, we'll do 6 times 2 squared minus 6 times 2 plus 6. This gives us 24 minus 12 plus 6. This gives us 12 plus 6, which is 18. That would be the answer for this type of problem. We already answered this one, but we'll go over it quickly again just to refresh. This one is saying the plot below represents the function f of x, and it wants us to find what the y value is when x equals 3, and that's going to be +1. Find the sum of the polynomials f of x equals 8x squared plus 6x plus 2, and g of x equals 4x squared minus 3x minus 1. We will get, so we'll do 8x squared plus 6x plus 2 plus 4x squared minus 3x minus 1. Now, if you remember, sum means addition. So now we can combine like terms. So these two are like terms, and then these two are like terms, and these two are like terms. So we can combine them. 8 plus 4 is equal to 12, and then we keep the x squared. 6 plus 4 is, 6 minus 3 is going to be equal to +3, so plus 3x. And then 2 minus 1 is equal to +1, so we'll do +1. And this would be your answer for that problem. This one wants us to simplify this, basically do the operations. So we have 8x squared minus 2x minus 8 plus -7, which is the same as, too big of an eraser, minus 7 minus 3x minus 6. Now when you see this negative sign and these parentheses, that means it's going to distribute to each of these terms. So it's going to flip the signs of each of these terms. So instead of +3x cubed, we have minus 3x cubed, and then plus 9x squared, and then minus 1. And now we can figure out which ones are like terms. So we have this and this, this and this, these, and these, and then this. So, and then I like to write it in descending order. So 3x cubed, that takes care of this term. And then 8x squared plus 9x squared is going to give you 17x squared. So plus 17x squared. So these terms are taken care of. Then we look at the -2x and the -3x. So that gives you -5x. That takes care of these terms. And then we have -8 minus 7 minus 1, which will give you -16. and that'll take care of those terms. So this is your new answer. This one's telling us to find the difference, and so we have, and it's f of x minus g of x, so 6x to the 5th plus x squared plus 3 of x minus, and then it's helpful to put the g of x in parentheses, minus 3x 5 to the 5th minus 7x squared minus 5. And now what we can do is distribute this negative to each of our terms. So we have 6x to the 5th plus x squared plus 3x to the 5th because a negative times a negative, plus 7x squared because a negative times a negative, and then plus 5. Now we can combine like terms. So we'll get 9x to the 5th, and then plus 8x squared plus 3x plus 5. And that would be your answer for this problem. The next is going to say find f of x minus g of x plus h of x. And then it gives us the list of the equations. So now we just want to plug them in. So negative 2x to the 5th plus 8x to the 4th minus 11x cubed minus 6x squared. And then we want minus g of x. So minus negative 9x to the 5th plus 10x to the 4th plus 4x to the third minus 12x squared. And we'll close parentheses on there, and then plus h, which is going to be 9x to the 5th, 5x to the third, x squared, and then minus 8. And then I'm not going to do it because it will take kind of a long time, but then you would just basically combine the terms. You'd need to distribute the negative out first. But then it's just a game of, okay, this one's similar, this one's similar, this one's similar, and so on. Just it's helpful to underline and then cross out. This one's dealing with the exponent rules, which we talked about briefly a moment ago. Since these two are multiplied together, the exponents are going to add. So we have a of 8 to the 8th. Also, the bases do need to be the same when you are multiplying to combine your exponents. Then we have c cubed times c of 8 times c to the 5th. And that is going to give you 16. So c to the 16. Unless I did math wrong. And this should be y to the 14th times b to the 4th, because b and y are not like terms. And then this one stays the same, a to the 6th times c to the 8th. Now, I don't remember how Lumen wants this. It may not want this multiplication sign in between. That's perfectly fine. You don't even need the multiplication sign for it to be valid. Next, we're going to multiply these two terms. Now, one thing to note is when we're multiplying, we still are going to be kind of combining like terms, even if they aren't the like terms technically. Like, we wouldn't be able to add these two terms. But we're going to say, okay, we have a negative 5 and a 3, and these two are going to turn into negative 15. So we're just multiplying like normal. And then we're going to have an a to the 7th, because these two are multiplied, the a cubed and the a to the 4th. So that would be our answer. Next, we're going to multiply again. I just wanted to do some more examples of this. We have 3 times 2, which is 6. We have a cubed times a, which is a to the 4th. And then we have b cubed times b to the 7th, which is going to be b to the 10th. That would be your answer. And then we have multiply the following and simplify your results. This term would multiply to both, so we'd have 8 times 4, which is going to be 32. And then we'd have an x squared. And then we'd have an 8 times 6, which is going to be, I believe, 42. Let me double check on that. My bad, 48. And it would be plus 48x. And that would be how you do that one. Now this one we have to multiply both of these things. So for some reason I've had students in the past call it like crab arms. I don't understand that 100%, but I kind of get it because they look like little crab arms. But this one we say, okay, what's negative 4x times x? That's going to give you negative 4 x squared. What's negative 4x plus 3? That's going to give you negative 12x what is 2 times x? That's going to give you positive 2x. And then what is 2 times 3? And that's going to give you 6, positive 6. And then these 12 and 2, these will combine to be negative 10x. And that is your answer. You just got to multiply every term by every term. And the same would apply here. I'm not going to do it for this one because it's a lot of time. But this one would be this times this times this, this times this times this. It's useful to like figure out which ones are which by doing that method. Now we're going to be talking about multiply the polynomial functions. Find the product of f of x equals negative 4x cubed minus 2x squared minus 7x, and g of x equals negative 6x. So we'll do negative 4x cubed minus 2x squared minus 7x, and then that's going to be multiplied by negative 6x. And this is going to be exactly the same as what we did before. So bloom, bloom, bloom. And then you get whatever that was, and I'll set this one up too. You get negative x. Well, I like starting with the smaller ones just because it works better in my brain. But you can do it however you'd like. X third minus 2 of x squared plus 4 of x, and then it'd be boom, boom, boom. And then finally 7x times negative 7x to the fourth minus 2x to the third plus 7x squared minus 5x. And then you do boom, 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 boom. And yeah, that would be your work. And you'd need to actually multiply those out for the answer. And then combine like terms if that's an option. Yeah, so if you have any questions, please let me know, and I will answer as soon as possible. I tried to go kind of quick, but I understand that I was missing some of the complexity of this. So if you have more questions or are confused about some of the steps that I took in this video, please let me know, and I'll answer as soon as possible. Have a good one.